Okay, this is problem number 8 from the Energy Primer. At first glance, this problem looks really confusing and complicated, especially if you haven't had any physics and you're reading all these terms, ampere hours and volts and amps, and you have no idea what it all means. First of all, look up what some of it means. Google some of these words. Make yourself a little bit more familiar with it. Second of all, you don't actually need to understand it that well in order to do the math. If you just follow the units, the answer comes out. The whole first part is just explaining this very last piece. The only piece we're interested in is this very last piece, that a D-cell battery delivers about 4.5 watt-hours of electrical energy. So that's not much. You know, we're used to talking about kilowatt hours and megawatt, even gigawatt, not a plain old watt hour. So 4.5 watt-hours of energy coming from this D-cell battery. And what it wants you to do is it says convert this energy to kilowatt hours and compare the cost derived in this manner to that of standard grid-based electricity. In other words, if you used a battery, how much would it cost to use the battery versus, here's your little radio that you want to play some music. So here's your little radio. Should you use the battery or should you plug it into the wall, meaning you're connecting to the grid? This is actually an extremely simple problem. It's saying if you connect to that grid, you're only going to pay 10 cents per kilowatt hour that you use. Well, the question is, how many kilowatt hours would you get out of that battery? And that first part there said that battery would give you 4.5 watt hours. If you look at your conversion sheet, a watt hour would be here with no prefix. So kilowatt is 10 to the 3 more, is 1,000 times more. Just the same way a kilometer is 1,000 times more than a meter. So a kilowatt hour is 1,000 times bigger unit. So if you're going to convert to this bigger unit, it's going to be fewer of these. So you're going to need this number to get smaller because your unit is getting bigger. So it's 0.0045 kilowatt hours. So that's how many kilowatt hours your battery is supplying. If you don't want to do it that way, you could do it like this. 4.5 watt hours of energy coming from that battery. And you know every 1 kilowatt hour has 10 to the 3rd watt hours. Watt hours cancel. So you're dividing by 1,000 and you get the same number. So 0.0045 kilowatt hours of energy would be provided by that battery. So what's the cost analysis? Well, it says that the battery costs $1, which doesn't seem like much. $1 for the battery. So, but you're paying $1 for an incredibly small amount of energy. So in other words, you're paying $1 for only 0.0045 kilowatt hours of energy. So how much would you be paying, X? How much would you be paying for at that rate, how much would you be paying for 1 kilowatt hour? If you're willing to pay $1 for this tiny fraction of a kilowatt hour, how much would a whole kilowatt hour cost you? And by simple cross multiplying, you see your X works out to be $222 per kilowatt hour. That's how much you're paying if you were to use a whole kilowatt hour of energy by using batteries versus plugging into the grid and only paying 10 cents for a kilowatt hour. So next time you're going to play your radio and you've got batteries in it but you see a plug nearby, plug it in. You're saving huge amounts of money in the long run. That dollar might not seem like much, but for the incredibly small output of energy you're getting, over the long run, once you use a lot of kilowatt hours, you would end up paying a ton of money compared to plugging into the grid.